December 19th, 2025 has passed. The moment the world held its breath for came and went. Atlas made its closest approach to Earth at 270 million kilometers, and to the casual observer, nothing happened. No alien mothership, no cosmic revelation, just a faint speck of light moving through the constellation of Lepus. But if you think the story ended on December 19th, you haven't been paying attention to what's coming next. Because 3.I Atlas isn't leaping quietly, it's heading toward the largest planet in our solar system, and what happens when it gets there in March 2026 might answer every question we've been asking since this object first appeared in our telescopes. Welcome back. Today we're going to walk through exactly what 2026 holds for this interstellar visitor, the Jupiter encounter in March, the data we'll collect, or the anomalies we'll finally be able to explain or confirm, and most importantly, what it means for humanity's understanding of our place in the cosmos. If you want to know what the next chapter of this story looks like, make sure you're subscribed. Because the timeline I'm about to lay out suggests that 2026 won't be the year we forget about 3I Atlas. It will be the year we finally understand what it really is. Let's start with where we are right now, in late December 2025. 3.3I Atlas has passed Earth. It's currently moving outward through the inner solar system at approximately 60 kilometers per second. That's 129,000 miles per hour, fast enough to cross the distance from Earth to the Moon in just over an hour. The object is dimming as it moves away from the Sun, its brightness is dropping. The coma, that cloud of gas and dust surrounding the nucleus, is beginning to fade. The spectacular tail that wobbled before perihelion is becoming less prominent. Ground-based telescopes is becoming harder to observe. The signal-to-noise ratio is dropping. The object is blending into the background stars, and within weeks, it will be too faint for most amateur telescopes to detect. But it's not gone, and it's not done. The trajectory calculations are precise. 3.I Atlas is heading for a close encounter with Jupiter. The date is March 16th, 2026. The distance will be approximately 53 million kilometers from the gas giant's cloud tops. In cosmic terms, this is a near miss. It's close enough for Jupiter's massive gravity to significantly alter the comet's trajectory, close enough for the planet's intense magnetic field to interact with any charged particles in the coma, close enough for our spacecraft at Jupiter to potentially observe it, and that's where things get interesting. NASA's Juno spacecraft has been orbiting Jupiter since 2016. Its primary mission was to study the planet's composition. Gravity field, magnetic field, and polar magnetosphere. It's been wildly successful, sending back stunning images of Jupiter's swirling clouds and revealing secrets about the planet's interior. But in March 2026, Juno will have a new target, an interstellar visitor passing through its neighborhood. Now, NASA has been careful to manage expectations. They've stated publicly that Juno wasn't designed to track fast-moving interstellar objects. Its camera, Juno Cam, is a public outreach instrument, not a high-speed tracking telescope. The spacecraft's orbit and instrument pointing are optimized for Jupiter, not for objects passing by at 60 kilometers per second. But here's what they're not saying publicly. Juno has other instruments beyond Juno Cam. It has a microwave radiometer that can detect thermal emissions. It has a magnetometer that can sense magnetic field disturbances. It has particle detectors that can measure charged particles in the environment. If 3I Atlas passes within 53 million kilometers of Jupiter, these instruments will detect it. They'll measure its thermal signature. They'll sense any magnetic fields it generates or disrupts. They'll detect any particles it's shedding. And most importantly, if 3I Atlas is transmitting any kind of signal, if it's using Jupiter's magnetosphere as an amplifier, Juno will hear it. This is why the Jupiter encounter matters. It's not just about getting closer images. It's about putting a sophisticated scientific spacecraft in the same neighborhood as an object that has defied explanation for months. Let me walk you through what we expect to see in March 2026. based on the current data and trajectory models. First, the approach phase. In early March, 3-point atlas will be visible to Jupiter-based observations. The Hubble Space Telescope will likely be tasked to observe it. The James Webb Space Telescope might turn its infrared eyes toward it. Ground-based observatories will track it as it moves through the outer solar system. We'll be watching for several key things. Is the object still outgassing? The spectroscopic signature should tell us if it's still venting water, carbon monoxide, hydrogen cyanide, or other volatiles. If it's not, if the outgassing has stopped, that tells us something important about its composition and internal structure. Is the non-gravitational acceleration continuing? The slight push that we detected as it left the inner solar system, is it still there? If it stops, it suggests the acceleration was indeed caused by outgassing that has now ceased. If it continues, it suggests something else is providing thrust. Is the anti-tail still present? That massive structure, larger than the distance from Earth to the Moon, that wobbled before perihelion, is it still there? Is it still pointing toward the sun, or is it dissipated? These observations in early March will set the stage for the main event. On March 16th, 3Y Atlas will reach its closest approach to Jupiter. At 53 million kilometers, it's not close enough to be captured by Jupiter's gravity. It's not going to become a moon, but it is close enough for a significant gravitational interaction. Jupiter will bend the comet's trajectory. The object will gain velocity from the encounter, slingshotting around the gas giant and accelerating even faster out of the solar system. This is called a gravity assist, and it's the same technique we use to send spacecraft to the outer planets. But here's where it gets interesting. The amount of velocity change depends on the exact trajectory and the mass of the object. If we can measure how much 3I Atlas's path changes during the Jupiter encounter, we can calculate its mass more precisely. And if we know its mass and we know its size, we can calculate its density, and density tells us what it's made of. Is it a loose rubble pile barely held together by its own weak gravity? Is it a solid chunk of rock and ice? Or is it something else entirely, something with a density that doesn't match any natural comet we've ever studied? The Jupiter encounter will give us that answer. But there's another aspect to the encounter that has scientists both excited and nervous. Jupiter's magnetosphere. Jupiter has the strongest magnetic field of any planet in the solar system. It's 20,000 times stronger than Earth's. The magnetosphere, the region of space dominated by this magnetic field, extends millions of kilometers from the planet. It's so large that if you could see it from Earth, it would appear larger than the full moon. This magnetosphere is filled with charged particles, radiation, plasma. It's a hostile environment. It's one of the reasons why sending spacecraft to Jupiter is so challenging. The radiation can damage electronics. The charged particles can interfere with instruments. But it's also a natural laboratory for studying how objects interact with magnetic fields. When 3I Atlas passes through Jupiter's magnetosphere, several things will happen. If the comet has any magnetic field of its own, Jupiter's field will interact with it. We'll see disturbances, ripples in the magnetosphere that Juno's magnetometer can detect. If the comet is shedding charged particles, if the coma contains ions, they'll be swept up by Jupiter's magnetic field. They'll spiral along the field lines. Some might even crash into Jupiter's atmosphere, creating auroras. And if the comet is transmitting any kind of electromagnetic signal, Jupiter's magnetosphere will act as an amplifier. The magnetic field can focus and boost radio waves. It's why Jupiter is one of the brightest radio sources in the solar system. This is the moment that has some researchers quietly excited. If 3I Atlas is artificial, if it's a probe, if it's been collecting data on our solar system, the Jupiter encounter is when it would transmit that data home. Why? Because Jupiter provides the perfect transmission boost. The magnetosphere amplifies the signal. The gravity assist provides a stable platform for pointing the antenna. And the timing, passing Jupiter on the way out of the system, is exactly when you'd want to send your final report. We'll be listening. The Allen Telescope Array will be pointed at Jupiter. The Green Bank Telescope will be monitoring. Radio observatories around the world will be searching for any anomalous signals. If 3I Atlas transmits, we'll hear it. And if we hear it, everything changes. But let's assume for a moment that we don't detect any artificial signals. Let's assume the Jupiter encounter reveals that 3I Atlas is, in fact, a natural object. What will we learn? We'll learn about the composition of interstellar comets. We'll get precise measurements of its mass, density, and internal structure. We'll understand how objects from other star systems differ from the comets that formed in our own solar system. We'll learn about outgassing behavior at large distances from the Sun. By March, 3I Atlas will be much colder than it was at perihelion. If it's still venting gas, that tells us something important about the volatility of its ices. If it's not, we'll understand the threshold at which cometary activity ceases. We'll learn about the long-term evolution of interstellar objects. How do they change as they pass through a star system? How much mass do they lose? How does their structure evolve? These are valuable scientific questions. Even if 3I Atlas is completely natural, the Jupiter encounter will provide data that advances our understanding of planetary science and cometary physics. But there's a reason why so many researchers are holding their breath for March 2026. It's because of the anomalies, the things about 3I Atlas that don't fit the natural comet model. Let me remind you of what we've observed so far. The anti-tail that wobbled before perihelion, a structure larger than the Earth-Moon distance, oscillating with a frequency that doesn't match any known natural process. A tail that pointed toward the sun, defying the solar wind. The dimming pattern, regular pulses of brightness changes, occurring every 144 minutes with clockwork precision. A light curve that looks more like a signal than a tumbling rock. The non-gravitational acceleration, a push that requires massive mass loss, but without the corresponding tail of gas and dust that should be visible. The trajectory, an object that entered the solar system aligned with the ecliptic plane, passed close to Mars, Earth, and now Jupiter, all with surgical precision. The composition, spectroscopic analysis showing heavy elements, complex organic molecules, and a nickel-to-iron ratio that looks more like industrial alloy than natural rock. The size estimate, a nucleus of approximately 1 kilometer that shouldn't be able to produce the observed outgassing without disintegrating. Each of these anomalies, taken individually, can be explained away. Maybe the anti-tail was an optical illusion. Maybe the dimming pattern was a coincidence. Maybe the trajectory was just luck. But all of them together, that's what makes 3I Atlas so compelling. It's the pattern of anomalies, the accumulation of unlikely events, that suggests something more than a random rock from interstellar space. The Jupiter encounter will test these anomalies. It will either explain them through natural processes or confirm that we're dealing with something unprecedented. Let's walk through some specific scenarios for what might happen in March 2026. Scenario 1, the natural comet confirmation. In this scenario, the Jupiter encounter reveals that all the anomalies have natural explanations. The anti-tail was indeed an optical illusion, confirmed by the viewing geometry from Jupiter. The dimming pattern was caused by an irregular rotation that becomes apparent with better observations. The non-gravitational acceleration was outgassing that we simply couldn't see from Earth due to the composition of the gas. The trajectory, while unusual, was just statistical luck. The composition, while rare, falls within the range of possible natural variation. The size estimate was wrong, and better measurements from Juno show a larger nucleus that can sustain the observed activity. In this scenario, 3I Atlas is a fascinating but ultimately natural interstellar comet. It teaches us about the diversity of objects in the galaxy, but it doesn't challenge our fundamental understanding of physics or our place in the universe. This is the scenario that most scientists publicly expect. It's the conservative interpretation. It's the explanation that requires the fewest assumptions, but it's not the only scenario. Scenario 2, the artificial probe confirmation. In this scenario, the Jupiter encounter provides evidence that 3I Atlas is not natural. Juno detects a strong, organized magnetic field that doesn't match any natural comet. The magnetometer readings show a field structure that looks engineered, with symmetries and strengths that suggest artificial generation. The thermal signature is wrong. Instead of cooling uniformly as it moves away from the sun, the object shows hot spots, localized areas of heat generation that suggest internal power sources. The trajectory adjustment during the Jupiter encounter is too precise. The object makes course corrections that can't be explained by outgassing. It's actively navigating, using Jupiter's gravity not just for a boost, but for a specific trajectory change. And most dramatically, Juno detects a transmission, a burst of radio waves, tightly focused, beamed toward a specific point in the sky. The signal is structured, modulated, carrying information. It's not natural. It's a message. In this scenario, 3I Atlas is confirmed as an artificial probe, an object built by an intelligence from another star system, a scout, a messenger, a piece of technology that has traveled light years to visit our solar system. This is the scenario that keeps researchers awake at night, not because it's likely, but because it's possible. And if it's true, it changes everything. But there's a third scenario, one that's perhaps more unsettling than either confirmation. Scenario 3, the ambiguous result. In this scenario, the Jupiter encounter provides more data, but that data doesn't resolve the mystery. Some anomalies are explained, others remain. New observations reveal new puzzles. Maybe Juno detects a weak magnetic field, but it's unclear if it's natural or artificial. Maybe the thermal signature is unusual, but not definitively non-natural. Maybe there are trajectory adjustments, but they could be explained by complex outgassing patterns. Maybe there's a radio signal, but it's faint, ambiguous, possibly just interference. Or maybe there's no signal at all, but the other anomalies persist. In this scenario, we're left with more questions than answers. The debate continues. Some scientists argue for natural explanations. Others insist the evidence points to artificial origin. The data is rich, but inconclusive. This might be the most frustrating scenario, but it's also perhaps the most likely, because nature rarely provides clear, unambiguous answers. The universe is complex, objects can be strange without being artificial, and our instruments, while sophisticated, have limits. So which scenario will play out in March 2026? We don't know. We can't know until the observations are made and the data is analyzed. But here's what we can say with certainty. The Jupiter encounter will be the most important observational opportunity for 3I Atlas. It's our last chance to study this object up close before it leaves the solar system forever. After Jupiter, 3I Atlas will continue outward. It will pass Saturn's orbit in late 2026. It will cross Uranus's orbit in 2028, Neptune in 2030, and by the mid-2030s, it will be beyond Pluto, entering the Kuiper Belt. By 2040, it will be in the Oort cloud, that distant shell of icy bodies at the edge of the solar system. And by 2050, it will cross the heliopause, the boundary where the sun's influence ends and true interstellar space begins. It will be gone. Unreachable, a mystery that passed through our neighborhood and left before we could fully understand it. Unless we act in March 2026. There's been discussion, quiet but serious, about sending a mission to 3I Atlas. Not to intercept it, that's impossible with current technology, but to tag it, to attach something to it. To send a message or a payload that rides along as it leaves the solar system. Avi Loeb has proposed using high-powered lasers to engrave a message on its surface. A cosmic graffiti announcing that humanity was here, that we saw it, that we tried to communicate. Others have suggested a more ambitious approach. A small probe, launched on a fast trajectory, designed to rendezvous with 3I Atlas during the Jupiter encounter. Not to land, but to fly alongside it, to study it up close, to perhaps attach a transmitter that could send data back to Earth for years as the object travels into deep space. The technical challenges are enormous. The object is moving at 60 kilometers per second. Matching that velocity requires a rocket more powerful than anything we've built for interplanetary missions. The launch window is narrow. We'd need to launch in January or February 2026 to reach Jupiter in time, and the cost would be substantial. Hundreds of millions of dollars for a mission that might not succeed, that might not provide definitive answers, even if it does. But the scientific return could be unprecedented. If we could place instruments on or near 3I Atlas, if we could study it up close during the Jupiter encounter, we'd answer questions that ground-based observations can't resolve. Is it natural or artificial? What's it made of? What's its internal structure? Is it transmitting? Is it collecting data? Is it alive in some sense we don't understand? These questions might be worth the cost. They might be worth the risk. But as of late December 2025, no such mission has been approved. No rocket is being prepared. No spacecraft is being built. So we're left with remote observations. Telescopes on Earth and in space, Juno at Jupiter, and the hope that the data we collect in March 2026 will be enough to solve the mystery. Let me paint a picture of what March 16, 2026 might look like. It's early morning at the Juno Mission Control Center at NASA's Jet Propulsion Laboratory in Pasadena, California. The team has been preparing for this moment for months. They've calculated the exact time when 3I Atlas will pass through Juno's field of view. They've programmed the spacecraft to turn its instruments toward the predicted location. Juno is 53 million kilometers from the comet, but its instruments are sensitive. The magnetometer is recording. The microwave radiometer is scanning. The particle detectors are active. At observatories around the world, telescopes are pointed at Jupiter. The Hubble Space Telescope has been scheduled for observations. The James Webb Space Telescope is monitoring in infrared. Radio telescopes are listening. And then, at the predicted moment, the data starts coming in. Juno's magnetometer shows a spike, a disturbance in Jupiter's magnetic field. Something is passing through, something with its own magnetic signature. The microwave radiometer detects a thermal source, faint but distinct, an object warmer than it should be at this distance from the sun. The particle detectors register an increase in charged particles. The comet's coma is interacting with Jupiter's magnetosphere, creating a wake of ions. And then, from the radio telescopes on Earth, a signal, faint, structured, modulated, coming from the direction of Jupiter, coming from the location where 3I Atlas should be. The signal lasts for 72 seconds, the same duration as the famous WOW signal from 1977, and then it stops. The data is recorded, the observations are complete, and the analysis begins. This is the moment we're waiting for. This is what March 2026 might bring. Or maybe it brings nothing. Maybe Juno detects a faint, cold object passing by. Maybe the magnetometer shows no anomalies. Maybe the radio telescopes hear only silence. Maybe 3I Atlas passes Jupiter as quietly as it passed Earth, a rock in space, following the laws of physics, doing nothing unexpected, and maybe that's okay. Maybe the mystery remaining unsolved is part of the story. Maybe the universe doesn't owe us clear answers. But I don't think that's what's going to happen. I think March 2026 is going to be significant. I think the Jupiter encounter is going to reveal something important about 3I Atlas, because the pattern of anomalies is too consistent. The trajectory is too precise. The timing is too perfect. This object entered our solar system from above the ecliptic plane. It dove down past the sun at exactly the right angle to pass close to Earth. It's now heading to Jupiter at exactly the right time for a gravity assist, and it's pointing toward Epsilon Tauri, a star system 146 light-years away in the Hyades cluster. That's not random. That's not luck. That's navigation. And if it's navigation, then 3I Atlas is not just a rock. It's a vehicle, and vehicles have purposes. They have missions. They have destinations. The Jupiter encounter might reveal that purpose. It might show us the mission. It might confirm the destination. Or it might just deepen the mystery. It might show us that 3I Atlas is even stranger than we thought, that the anomalies we've detected are just the surface, that there are layers of complexity we haven't even begun to understand. Either way, March 2026 is going to be important. It's going to be a milestone in the story of 3I Atlas, and it's going to shape how we think about interstellar objects for decades to come. But 2026 doesn't end with the Jupiter encounter. There's more to come. After Jupiter, 3I Atlas will continue its journey outward, and as it moves into the outer solar system, we'll have opportunities to observe it with different instruments, from different angles, under different conditions. The James Webb Space Telescope, with its powerful infrared capabilities, will be able to track the object even as it dims. Webb can see heat signatures that visible light telescopes miss. It can detect molecules in the coma that other instruments can't resolve. In late 2026, as 3I Atlas passes Saturn's orbit, Webb will observe it. We'll get spectroscopic data on its composition at large distances from the Sun. We'll see if the outgassing continues or if it stops. We'll measure the temperature of the nucleus and see if it matches predictions for a natural comet. And we'll look for something else, something that would be definitive proof of artificial origin. We'll look for course corrections. If 3i Atlas is a probe, it needs to maintain its trajectory. As it moves through the outer solar system, gravitational perturbations from the planets will slightly alter its path. A natural object would drift, its trajectory slowly changing in response to these perturbations. But an artificial object would correct. It would make small adjustments to stay on course, and those adjustments would be detectable. If we see 3i Atlas making course corrections in late 2026 or 2027, corrections that can't be explained by outgassing, that would be strong evidence of artificial propulsion. We'll be watching for that, tracking its position with precision, comparing its actual trajectory to the predicted path, looking for deviations that suggest active navigation. And there's one more thing we'll be watching for in 2026 and beyond: the fragments. Remember, the scientific papers analyzing 3i Atlas's non-gravitational acceleration suggested that the momentum could be dominated by the ejection of fragments, not just gas, but solid chunks of material. If 3i Atlas ejected fragments during its perihelion passage, those fragments are still out there. They're on slightly different trajectories than the main body. Some might be moving faster, some slower. Some might be on paths that keep them in the inner solar system. We'll be searching for those fragments, looking for small objects on orbits similar to 3i Atlas, trying to determine if they're natural debris or something else. Because if those fragments are artificial, if they're probes or sensors or seeds, they might still be active. They might be collecting data, they might be transmitting, and if we can find them, if we can study them, they might tell us more about 3i Atlas than the main object ever could. This is the long game, the multi-year observation campaign that will continue through 2026, 2027, and beyond, tracking 3i Atlas as it leaves, searching for fragments, looking for signals, trying to piece together the complete picture of what this object is and what it's doing in our solar system. But let's zoom out for a moment. Let's think about what 2026 means in the broader context of humanity's search for life and intelligence beyond Earth. For decades, we've been searching the skies for signals from extraterrestrial civilizations. We've built radio telescopes. We've scanned millions of stars. We've listened for messages that might be crossing the galaxy, and we've found nothing. No confirmed signals, no evidence of technology, no proof that we're not alone. But 3i Atlas represents a different approach to the search. Instead of listening for signals from distant stars, we're examining an object that came to us, an interstellar visitor that entered our solar system, passed close to our planet, and is now leaving. If this object is artificial, if it's a probe sent by another civilization, then we don't need to search the galaxy for evidence of intelligence. The evidence came to us. And that changes everything. It means that interstellar travel is possible, that civilizations can send probes between star systems, that the galaxy might be full of these objects, traveling from star to star, collecting data, exploring, searching. It means that we're not isolated, that our solar system is part of a larger network, that we've been visited, observed, cataloged. And it means that the next step in the search for extraterrestrial intelligence isn't building bigger radio telescopes. It's studying the interstellar objects that pass through our neighborhood. Because if 3i Atlas is a probe, it's probably not the only one. There are likely others. Other objects from other civilizations, traveling through the galaxy, visiting star systems, collecting information. And now that we know to look for them, now that we have the technology to detect and study them, we can find them. 2026 might be the year we confirm that we're not alone, not through a radio signal from a distant star, but through an object that came to visit us. Or 2026 might be the year we confirm that 3i Atlas is natural, that the anomalies have explanations, that the universe is full of strange objects, but not artificial ones. Either way, 2026 will be significant. It will be a turning point in our understanding of interstellar objects and our place in the cosmos. As we approach the end of 2025 and look forward to 2026, I want to leave you with a thought. We're living through a unique moment in human history. We're the first generation to detect and study interstellar objects. We're the first to have the technology to analyze them in detail. We're the first to seriously consider the possibility that some of them might be artificial. Our ancestors looked up at the stars and wondered if we were alone. They imagined other worlds, other civilizations, other intelligences, but they had no way to know. No way to test their ideas, no way to search for evidence. We have have that ability now. We have telescopes that can see across the galaxy. We have instruments that can analyze the composition of objects light years away. We have the knowledge and the tools to search for life and intelligence beyond Earth. And 3i Atlas might be the first real test of that search. The first object that forces us to seriously consider whether we've found evidence of extraterrestrial technology. March 2026 will be crucial. The Jupiter encounter will provide data that could resolve the mystery or deepen it. The observations we make, the signals we detect or don't detect, the anomalies we explain or can't explain, will shape the conversation for years to come. But regardless of what we find, regardless of whether 3i Atlas is natural or artificial, the search will continue. More interstellar objects will arrive. We'll study them. We'll learn from them. We'll gradually build a picture of what's out there in the galaxy. And maybe, someday, we'll find definitive proof that we're not alone, that intelligence exists beyond Earth, that the universe is full of life and civilization and wonder. Or maybe we'll find that we are alone, that Earth is unique, that consciousness is rare, that we're the only ones asking these questions. Either answer would be profound, either answer would change how we see ourselves and our place in the cosmos. But we won't get that answer by sitting still. We won't get it by ignoring the evidence. We won't get it by dismissing anomalies because they make us uncomfortable. We'll get it by looking, by observing, by analyzing, by asking difficult questions and following the data wherever it leads. That's what 2026 represents. A year of observation, a year of analysis, a year of questions, and maybe, just maybe, a year of answers. Stay tuned. Keep watching the skies, and remember that the universe is vast, ancient, and full of mysteries we're only beginning to understand. 3i Atlas is one of those mysteries, and in 2026, we're going to learn more about it than we ever have before. The countdown to Jupiter has begun, and whatever we find there will shape the future of astronomy, astrobiology, and humanity's search for our place in the universe. This is what 2026 will show us, not just data about a comet, but insight into the nature of the cosmos itself. Are we alone? Are we being visited? Are we part of a larger galactic community? The answers might be waiting at